Okay. Unit 3, first quiz review. So remember, when you have a set of numbers in a bubble or in a list or a table, in that case is where the domain is just the list of the values. And the range here would be -3 and 6, and that's it. Okay? Now, is it a function? -1 has one output, 2 has one output, and 3 has one output. So the answer is yes. And you can just say each x, or input, has only one y, or output. Anything like that's fine. And remember, it's okay to get 6 more than one way. Think back to the calculator analogy. Is it okay to get 10 more than one way? Of course it is. You can do 5 plus 5, 20 minus 10, 100 divided by 10, and so forth. Here, we have a list for number 2. Notice -1 gives me 1, -3, and 2. So what is my domain? I don't have to write -1 3 times. It's just -1 and 2. My range is 1, -3, 2, and +3. Is it a function? Definitely not. Why? You can be very specific. -1 has multiple, or you could say 3 outputs. The domain for number 3. Again, list the x values. -4, only have to write the 2 once, and 8. If you write the 2 twice, it's not a big deal. Range, -4, 2, 1, and 9. Notice, 2 x's. So, one time 2 gives me 2, another time it gives me 1. So the answer is no. And again, you can be specific or general. You can say multiple outputs for one input, or you could say 2 has multiple outputs. Okay, so now that we're on actual pictures, graphs, now is where we're going to not just put specific numbers for the domain and range. This is where we're going to use brackets and parentheses and infinities and negative infinities and so forth. So number 4, the arrows mean it keeps going on forever. So the domain is quite simply negative infinity, positive infinity. How far left? How far right? Range? How low? How high? And that's it. Is it a function? It passes the vertical line test, so yes. And you can just write that as your justification. Passes the line test. Number 5, it's going to keep going left forever and right forever. It's going to keep going down and keep going up. Is it a function? Yes, it is. Again, it passes the line test. Number 6, the domain. Now, it actually has a left edge. So how far left does it go? 1. And since it's a solid dot, we use a bracket. If it was an open dot, we'd use a parentheses. That's how far left. How far right? Forever. How low does it go? Well, it's going forever down and forever up. And the answer is no, because it does not pass the line test. Okay, the domain. It's hard to tell on this one. You can estimate, how far left does it go, or you're talking about the very corner of the star or the main part right there. So I would accept -8. If you wanted to estimate -8.5, that's fine. and it would be a bracket because it does touch there. And how far right? It looks like it comes just right to 2, okay, almost to 2. I would accept if you put a parentheses or a bracket because it doesn't quite hit 2. If you wanted to put 1.75 and put a bracket, that's fine. It's just the general idea. How low does it go? It looks like it goes to about -5.5. And again, on these, I'm not going to be picky whether you have a bracket or a parentheses. And how high does it go? It looks like it hits 8. So we're going to use a bracket. It's not a function because it is definitely not going to pass the vertical line test. Draw a picture of each type. Linear equation is basically any line. You could, do a positive slope, you could do a negative slope, you could do a y equals line, you could do an x equals line. Just the idea that it's a line. A quadratic, have some fun with it. It could be positive, it could be negative. Cubic is our snake. Absolute value is our V. Exponential growth is never going to hit, sorry my board's off a little bit, never going to hit 0. Exponential decay, the opposite direction, never going to hit 0. Square root looks like that, starting here. Constant, y equals 2. That's a horizontal line going through positive 2. Okay, what type of function is it? Well, we have to do some math on this. So we look at this and let's check addition and subtraction first. So 2 to 1 is -1, and then it's +1, and then it's +3, and then it's +5. Well, that's not linear. If you go to the second level, that's +2, +2, +2. When it matches on the second level, we know we have a quad. If these were all +4 in the first level, it would be linear. +1, +1. So, for example, these are all +1s. That's linear. +2, +6, +18, +54. Then times 3, times 3, times 3. If it goes up in terms of multiplication, it's exponential. Sorry, this board is being really strange today. Okay, identify the transformations and describe the transformation from each parent graph. Identify the type function, describe the transformation from the parent graph. So this is x to the first power, which makes it linear. The only change is this -3, which means it's going to move down 3 spaces. So the whole line is just going to drop down 3. This 2 right here means we have a quadratic. This -2 is going to move it down 2 spaces. This negative right here flips it. Now this is kind of a tricky one. If you put in the calculator, it's going to look like it's flipping it over, it is flipping it over the x-axis. Okay, so You just have to be careful how you enter it in. Okay, but it just makes it go upside down. So that's a frown instead of a smile. Just make sure you enter it correctly when you're using the calculator. Okay, so number 3, we have the absolute value bars. This +1 is going to make it move left 1. Remember, inside the bars is the opposite of what you think. So plus makes you think right, but it's actually left. And this is why I say use the calculator. Go to your calculator, put in y equals absolute value of x, the parent function, and then put in y equals the absolute value of x plus 1. Even if you're pretty sure that it moves left, why not take the extra 10-15 seconds to enter it in the calculator, hit graph, and make sure it moved left? You can be assured of getting it right if you use the calculator. And then this -3 out here is actually 2 things. Okay, so the 3 is going to make it narrower, or stretch it vertically, make it taller. And then the negative is going to flip it over axis. In other words, it's going to go upside down. Okay, a lot going on here. This is got a 2, so it's quadratic. This +2 is going to move it up 2 spaces. This 1/3 is going to make it wider. And this -1 inside, opposite of what you think, is going to make it move right 1. But remember, if you plug in the graphing calculator y equals x squared, parent function, and then under y2, enter all this. And remember for this, you put 1 divided by 3, parentheses x minus 1, parentheses squared plus 2. And at that point, you'll see how it's moving. You'll see it grow wider, move right, and up. We have an exponent. We have a number raised to an exponent, which means it's an exponential function. Since this is bigger than 1, it's technically growth. If that was a fraction less than 1, it would be decay. So the -3 up top is kind of like being in parentheses, so it's the opposite of what you think. It's going to move it right 3. And this +3 is going to move it up 3. Okay, on the next one, we have absolute value again. This is going to move it up 8. And the 2/3 is going to make it wider. Okay, I'm going to stop it here and save this in 2 parts. So the last few is also going to be kind of longer because it's going to involve a lot of using the graphing calculator. So stay tuned for part 2.